This is my Physics 30 AP STS project on the use of antimatter annihilation for space travel. Before we can understand antimatter, we first need to understand regular matter. This is all explained by the Standard Model. In the Standard Model, there are quarks, which include the up and down quarks, the charm and strange quarks, as well as the top and bottom quarks. There are also leptons. They include the electron, the muon, the tau, as well as their corresponding neutrinos. There are also the gauge bosons, which mediate the fundamental forces. They include the gluon, the photon, the Z boson, and the positive and negative W boson. And finally, there is the Higgs boson. Today, we only need to worry about the leptons and the quarks, as they are the only ones with antiparticles. More specifically, we are only going to talk about the up and down quarks, as well as the electron. Two up quarks and one down quark can combine to form a proton, whereas one up quark and two down quarks form a neutron. These three particles can now be combined to make up the atoms that make up the world around us. Now we can move on to antimatter and antimatter annihilation. For the up quark, there is an anti-up quark. For the down quark, there is an anti-down quark. And for the electron, there is an anti-electron, also known as a positron. In the same way that up and down quarks can be combined to form protons and neutrons, anti-up and down quarks can be combined to form anti-protons and neutrons. That means for all the atoms in the universe, we can create the antimatter equivalent of those same atoms. When a particle and its antiparticle collide, they annihilate, replacing each other with photons traveling 180 degrees from each other. All of the mass that has been annihilated turns into energy. This energy can be predicted thanks to Einstein's famous equation E = mc². To put this into perspective, a 1 kilogram log set on fire would release 16 million joules of energy. If you were to annihilate that same log, it would release 9 × 10⁻16 joules of energy. That's the equivalent of the nuclear bomb dropped on Hiroshima, 1,500 times. Now that we know about antimatter and its annihilation, we can move on to learn about how it can be applied to space travel. The main way to use the energy produced by the annihilation is to use light sails. All photons have momentum. This is equivalent to their energy divided by the speed of light. This momentum can be transferred into the light sail upon reflection off of it. This is a possible design for a light sail ship. The photons would be emitted towards the light sail, bounce off, and transfer the momentum, pushing the ship forward. The photons would then be expelled through the back of the ship. An equation can be derived where the mass of the matter annihilated times the speed of light divided by the mass of the ship will be equal to the final velocity of the ship. There are some problems with the light sail design. First of all, since the photons are of such high frequency, more often than not, instead of being reflected off of the light sail, they just pass right through. The second problem arises when you try and move antimatter. Because it annihilates into photons upon contact with regular matter, you can't just carry it around. The best way to contain antimatter with a charge is with a device known as a penning trap. This is a vacuum-sealed box with 2 positively charged plates and 2 negatively charged plates that create an electric field which suspends the particle. Thank you for listening to my presentation on the uses of antimatter annihilation in space travel.